Ever since there has been life, there have been illnesses, infections, and epidemics. In this episode, we are going to explore how epidemics work and how medicine has evolved to cope with the challenges of new diseases. We will study tuberculosis, chikungunya, encephalitis, as well as jaundice in our journey through epidemics. Let's start off with an age-old disease, one that has troubled humanity since the time of the pharaohs, and even today remains one of the world's most infectious diseases and is one of the biggest killers in India. I am talking about tuberculosis.
It's been there for time immemorial. I mean, people are still debating, is it there during Neolithic time and how old is tuberculosis? Because as we start getting more and more sort of excavation done, archaeologists feel that TB was even present before human beings were there on this planet.
It is a disease that has propelled drama and cinema. All those scenes in old films where people coughed up blood into their handkerchief and died, well, they possibly suffered from TB, or consumption as it was called. In the pre-antibiotic era, it claimed a number of famous lives, including that of Kamala Nehru, wife of India's first Prime Minister, and Muhammad Ali Jinnah, the first Prime Minister of Pakistan. So how does this disease work? It is caused by a bacteria called Mycobacterium tuberculosis. This bacteria usually affects the lungs but can affect other parts of the body. When a person develops TB, they will have a range of symptoms like cough, fever, night sweats, weight loss, etc. It's also super infectious. People who are ill with TB can infect up to 10 to 15 other people through close contact over the course of a year. Without proper treatment, up to 2/3 of people ill with TB will die.
If the bacteria comes into someone's lungs, it can either cause active tuberculosis, which is TB, or the body tends to contain this, and there is what we call latent tuberculosis. There is a granuloma formed which stays latent, and the bacteria will stay there in a quiescent form without causing active infection. So tuberculosis can stay hidden in the body for years or for the whole lifetime. And it's believed that 1/3 of the global population has latent TB. So it's a huge number, that almost 2 billion people on this planet have the TB bacilli, and many of them will die with the TB bacilli.
Overall, about 5 to 10% of people with latent TB who do not receive treatment for it will become sick at some time in their lives. And once active, they will infect other people. Because of this chain of infection, there are about 22 lakh cases of TB in India every year, and an estimated 2.2 lakh die from this disease. The economic burden of tuberculosis is extremely high. Between 2006 and 2014, TB cost the Indian economy over 400 crore rupees. Before we see how India copes with tuberculosis, let's quickly step back and see what an epidemic is. So when a disease is widespread to the point where it affects a disproportionately large number of people in a given area or population all at the same time, it is referred to as an epidemic. Epidemics grew as civilizations grew and traveled. Armies, colonizers, and traders all imported and exported disease. Thankfully, medical science also grew, coming up with solutions to many epidemics. The turning point was possibly when Edward Jenner came up with a vaccine that could protect people against the dreaded smallpox. In the 1800s, laboratory research by scientists like Louis Pasteur and Koch advanced our understanding of diseases and epidemics. The next big landmark in the fight against disease came with the invention of penicillin by Alexander Fleming. Through the 20th century, diseases began to decline and epidemics were smaller in scale. But still, ancient diseases like malaria kills lakhs even today, and newer ones like AIDS have disseminated large numbers in more recent times. So what is India doing to cope with the tuberculosis epidemic? We traveled to the National Institute of Research in Tuberculosis in Chennai to see some of the work being done on the ground to battle TB. Scientists at this institute have a multi-pronged approach to battle TB that includes the dissemination of information, better diagnostic tools and technologies, as well as the development of new drug regimes.
Previously, the duration of anti-TB treatment was quite long. It was almost 2 years anti-TB treatment. And our studies clearly showed that you can cut down the duration of treatment to 6 months. And that has been taken up by the government. So 6-month regimen is the standard regimen. Then we are studying at present, can we shorten the duration still further? The longer the duration is, the more chances the patient may default therapy. So if you have a shorter regimen, then probably the patient will be more adherent to treatment.
A big issue in the battle against TB is how it has now become drug resistant. Data shows that 6% of TB patients in India are multi-drug resistant. This means that the bacteria is resistant to isonic acid and rifampicin, two of the most effective TB drugs. Now the scary thing about this kind of TB is that when it infects another person, they will also have the drug-resistant strain of tuberculosis. Scientists in NIRT are working on creating a new mix of drugs to tackle this kind of TB. They are running trials in multiple centers on 4 different regimens to see which would be most effective in the battle against TB.
2 new drugs which have come in almost after 30-40 years are bedaquiline and delenamide. But along with that, new regimens, like I said, you don't need one drug. So you can't say that one drug has come and that's all. You need a regimen because you have to give more than one drug to control tuberculosis. And that is why newer regimens have come in, where different types of drugs, even what we call older drugs, are being tried to form a regimen which is effective so that you can cut the duration of treatment and cause rapid elimination of the bacteria.
Maybe this, along with the many measures to contain the spread of this disease, will change the TB narrative and bring about new results in this epidemic in our country. We now move to Delhi in the peak of the monsoon. The rains from June to September usually cause some flooding and create stagnant pools of water, ideal breeding conditions for mosquitoes. And one of the diseases that these deadly mosquitoes carry is called chikungunya, and this has plagued New Delhi every monsoon since 2006. Chikungunya, it's not a word that rolls easily off the Indian tongue. That is possibly because it is a Swahili word, meaning that which bends up, and we have been bending up.
The last explosive outbreak that we had was in 2006, which kind of affected 13-14 states in the country and more than 1 million population. And after that we didn't see, but sporadic cases continue to occur throughout. So this is a propensity the virus has. I mean, since 1983 we've seen that it occurs and then for many years we don't see it.
So what was this disease that took Delhi and so many other places by storm? And is there a way to protect oneself against it? And then a disease that killed hundreds of children in Uttar Pradesh. Keep watching after this break to find out more. We are exploring chikungunya in our journey through epidemics. First off, let's get a sense of how this disease works. Chikungunya is caused by a virus that is transmitted by mosquitoes. specifically the Aedes mosquitoes, which is the same mosquito that transmits malaria and dengue. People who contract the disease tend to suffer from a fever and severe joint pain, causing them to have a painful and contorted posture.
Chikungunya is a kind of fever which is spread through mosquitoes. It is actually in a way similar to presentation of other viral fevers like dengue fever. Dengue mostly patient presents with body pains or the muscle pains as a predominant symptom, whereas in chikungunya patients present more with joint pains. But in both the diseases they present with very sudden onset of fever.
The disease was first detected in 1952 in Africa, following an outbreak of the Makonde Plateau, a border area between Mozambique and Tanzania. In fact, the word chikungunya, which means to bend over, originates from a verb in the Kimakunde language. Now the virus lay relatively dormant until 2004 and then resurfaced in East Africa, in Kenya to be more specific. It then spread to islands in the Indian Ocean like Comoros and the Reunion Islands in 2005. It traveled with tourists to Europe and landed in India by 2005. The widening geographical scope of the virus is due to the expanding range of the mosquitoes that carry it. Increasing global temperatures, international travel, and population densities all contribute to allowing mosquitoes to take up residence in previously unoccupied areas.
Chikungunya is not a new thing for India. India had got chikungunya a long time back also, even in 70s, 80s. Then it went into hibernation. And in 2005-06, there was a resurgence. So many Andhra Pradesh, Madhya Pradesh, all those states were affected. And now chikungunya is well entrenched in the country. Just like dengue, chikungunya, H1N1, they are all now well entrenched.
Chikungunya fever displays interesting epidemiological profiles. Major epidemics appear and disappear cyclically, usually with an inter-epidemic period of 10 years, and sometimes it can even take over 30 years. Keeping this context in mind, let us see how Delhi coped with the chikungunya epidemic. Many hospitals set up special wards to cope with the influx of patients. Since there is no specific antiviral drug treatment for chikungunya, most of the treatment was directed primarily at relieving the symptoms, including the joint pain, using antipyretics, optimal analgesics, and fluids. The scale of the disease is so high because currently there is also no vaccine for chikungunya. However, there is a lot of work underway in different centers in India to develop one. We traveled to Bharat Biotech in Hyderabad to see what they are working on here.
2006, there was an epidemic in Kerala and Tamil Nadu, chikungunya. There was a time the given government of India was not believing that it's a chikungunya. And actually we were the first one to isolate the blood sample, sequence the virus genome, and filed a patent also on chikungunya. We were the first company to file a global patent on chikungunya vaccine. We have done all the preclinical toxicology. We proved that vaccine doesn't cause any arthritis problem, that we have done it. And we have done a phase 1 human clinical trial. It's shown safe. And now the data is coming out. And I think we would like to, after the phase 1 trial, complete, since it's completed, we need to go phase 2 and maybe license the product.
If these trials work, it will be possible to release a commercial vaccine for the same.
Based on the phase 1 data and animal data, once you vaccinated, you don't need a boosters again. So we are coming with either 2-dose vaccine or 3-dose. When suppose an infection occurs because the immune response is there, it immediately boosts. So you don't need that. So we have seen example of Japanese encephalitis, and we have seen rabies vaccine. Once you're given, it's a lifetime immunity.
And if this is effective, it could change the dialogue around chikungunya. However, until this happens, the onus lies on preventing the spread of the virus. The mosquito breeding sites across the city need to be contained, and proper methods of fumigation are essential.
See, I would say that precaution in terms of prevention, that I don't get it, which means again mosquito control measures. I protect myself against mosquito bites. So that can be individual, when we say during monsoon and post-monsoon, wear full sleeve clothes, don't sleep outdoors, particularly where the mosquitoes are. And the others are general measures, which is spraying and mosquito nets and not allowing water collections to happen.
Mosquito bites can have much more heart-rending consequences, as we will see in our next epidemic, where hundreds of children lost their lives. We need to travel to Gorakhpur in Uttar Pradesh to explore the genesis of the encephalitis epidemic here and its tragic aftermath. Encephalitis is an inflammation of the brain tissue. The most common cause is viral infections. In rare cases, it can be caused by bacteria or even fungi. There are two main types of encephalitis: primary and secondary. Primary encephalitis occurs when a virus directly infects the brain and spinal cord. Secondary encephalitis occurs when an infection starts elsewhere in the body and then travels to your brain. Now, the most common form of encephalitis is the Japanese encephalitis virus or JEV that travels from animals to humans through the mosquito. But strangely, the mosquito cannot pass it from human to human. The disease is found in many parts of India but is highly endemic in eastern UP, which means it is regularly found in this area. Why Gorakhpur, you may wonder? This is the nodal point because the main medical center, with more than 100 beds devoted to Japanese encephalitis, is in Gorakhpur. So cases from nearby districts are referred there for treatment. Unfortunately, the history of this disease in this area has been horrific. Records show that over 60 children have died in 2017 in Gorakhpur due to encephalitis. And this epidemic has claimed around 25,000 lives in the last 4 decades. There are several theories that the media has suggested as to why this happened. A lack of oxygen when it was needed, medical negligence, and carelessness are all theories that have been touted. In an attempt to rectify the problem, from May 2017, the UP government has launched a vaccination campaign in 38 districts across the state. Hopefully, this will create change and we will see a drop in these tragic deaths in the years to come. Though the reason the disease is so prevalent in these areas still remains a bit of a mystery. In many cases, finding out the cause and spread of these epidemics or outbreaks is a bit like a whodunit. What was the origin? Why was the spread? After the break, we are going to explore one such mystery that happened in Shimla. Our journey through epidemics brings us to Shimla in 2016, which was in the throes of a mysterious jaundice outbreak. The summer capital of the British India, Shimla, changed to the jaundice capital of the country in 2016 with 1,600 reported cases. Though unofficial estimates put the number even higher at around 10,000 cases. Now what was causing this? The worst jaundice outbreak since 1947. Before understanding the cause of the attack, let's understand what jaundice means scientifically. Jaundice itself is not a disease, but it's a symptom of several possible underlying illnesses. Actually, it is the medical term that describes yellowing of the skin and eyes. It is caused by too much bilirubin in the blood. Bilirubin is yellow pigment found in your red blood cells. The liver usually filters excess bilirubin from the bloodstream. But if something's wrong and your liver cannot do this, the bilirubin builds up and can cause your skin to look yellow. Medically, jaundice is called hepatitis. It is further broken down into 3 categories based on where it starts. Prehepatic, when it starts before the liver. hepatic, which is in the liver, and post-hepatic, which is after the liver. There are 5 main hepatitis viruses, referred to as types A, B, C, D, and E. Hepatitis B, C, and D usually occur as a result of contact with infected body fluids like blood products and sexual transmission. Hepatitis A and E are typically caused by the ingestion of contaminated food or water.
Jaundice is actually inflammation of liver. It is also called as hepatitis. And common symptoms are like mild fever, malaise, nausea, vomiting, dark urine, and at times body ache, abdominal pain. And there are several reasons for this hepatitis, like alcohol abuse, then drug toxicity, certain bacterial infections, certain viral infections.
Now, the jaundice epidemic in Shimla was hepatitis E, and figuring out the cause of this epidemic was a process of deduction, a bit like a whodunit. Experts from the National Institute of Virology, Pune, came to Shimla and took water samples from the Ashwani Khud water treatment plant and the sewage treatment plant in Malyana. These samples were then taken to the NIV campus in Pune, where they were tested. Scientists here then found that water samples from both plants tested positive for hepatitis E. They figured that the virus had origins in untreated sewage. By the time this discovery was made, 25% of Shimla's population was affected. The Shimla Municipal Corporation started an awareness campaign and sent notices to all the households connected to the sewerage network. By then, it was too late. To make sure this kind of epidemic does not repeat, there are monitoring mechanisms in place where water supplies to the city is regularly checked.
In 2016, November, December, we saw there were a few contaminated water samples, and we immediately informed those public health authorities, corporation engineers, like now there is water contamination and you better take care of your drinking water sources. So now they are taking care of their drinking water sources, and we are helping them to monitor their drinking water sources.
These mechanisms are strengthened in dry spells in this area, when water from the treatment plant rather than groundwater is being used by the city, to make sure that Shimla doesn't ever become the hub of jaundice again. Advances in science have removed the threats of many epidemics like polio, the plague, and smallpox. But as new diseases and mutated versions of older diseases hit our populations, medical innovation and disease prevention are the key to keeping epidemics under control.